Okay, so now this is the very final step to just plug in all the values. So after we got this vector analysis, then we can find the component, the vertical components of the VAF, right? That should be these values, and then this one, and then this one, and then now just sine of 30 degree will be 1/2, sine of 40 degree will be square root of 2 over 2, and then we see that this one can be calculated it depends on this one, right? So then we can just move cancel out 2 half on the both side, and we got this one. So this is just to demonstrate VAF by VBF, so that if we plug 3 into back into 2, then the whole equations just become the equations of one variable, so then we can solve it, right? If we just have 2, we cannot solve, so we need to substitute 3 into 2 again. So this is the one here, which becomes square root of 2 VBF, and then now we can just solve for BF. This value is just about 1.93, and then we got this one divided by this one, then this is the 20.7 meter per second. That's the length of these vectors here, and then we just need to plug it back into number 3 here. Then we can find the length of this one VAF, which is 29.3 meter per second. So then now we're done with the first question. They ask for the energy lost. What fraction of the original kinetic energy of plug A dissipates during the collisions? So we just focus on plug A. And like for plug B, initially it's just 0, so we can not determine the fraction, right? So anyways, in order to calculate the energy loss for plug A, we just need to calculate the change in the kinetic energy, and it's supposed to be like negative, right? Because the final is less than the initial. So in order to do the fraction, we just care about the magnitude, not the negative side. So I put them into a magnitude bracket, a modern bracket, and then we can see here we don't even need the mass, because the mass will cancel out, right? The initial just like 1/2 mass, and then the V initial square. So then from this we just simplify to have this one. Everything is measured in meter per second. That's why I don't include the unit here, because they cancel out each other. And then finally we got the fractions to be 0.46, which is about 46%. So that's it for this problem. So I hope that whenever you work with this problem with the change in the directions, then you can see that by analyzing them into the horizontal component and the vertical component like this, then it can help us to solve the problems. Or you can also try other way, as long as you can make use of the geometrical properties of these factors. Okay, thank you. See you in other problems. Good luck.